So far in the bridging, we've looked at working with some trig problems, and they've generally been defined what I would call explicitly. They tell you what to do. With your stuff at A level, a lot of times you won't be told this is the cosine rule, this is the sine rule, or use Pythagoras. You'll just be expected to pull that from the top of your head and decide which is the best. And I'm just going to do a couple of different problems with you to get you thinking about the sort of, not necessarily questions that would come up, but ways of thinking about them. Okay, here's one. Find the remaining angles and sides of a triangle ABC if B is 81 degrees. So angle B, big B, little b is 12 and C is 11. So this is suggesting that if I sketch this up, and again, at A level, sketching is incredibly important. It doesn't have to be accurate. So let's say now this is going to be, and let's just grab this. This will be now big B. This will be angle big B at the top. Right, so what we got here is big B. Now big B, we're told, is 81 degrees. So little b, its opposite, will just be here at 12. We know, and we can call this one A, little a, and this is going to be little c. Now little c is going to be equal to 11. So what do we need to do? We need to find the remaining angles and sides. So automatically we can get to this one right here. We can get to this angle. We know to find an angle that we can say, and we'll call this big C, we'll say that sine C over 11 is equal to sine B, which is 81, over the 12, which is just here. So to get the angle size C, we can say C is equal to sine to the minus 1 of 11 lots of sine 81 by simply multiplying up here, sine 81 over 12. And let's see what that does for us. So we'll grab a calculator. Okay, and we need to be in degrees mode, which we are, and we'll do shift mode 3 while we are in degrees mode. So shift sine of 11 sine 81 over 12, and this will give us that angle right there. Okay, 64.87. So this one right here is 64.87. In A level as well, it's incredibly important to work to higher level degrees of accuracy. I'm going to leave that in my calculator. This angle right here, if we think about it, this angle size is going to be 180, okay, minus the 81 minus the value we've just found. So looking at in the calculator now, 180 minus 81 minus that answer will give us the size of this angle. Exactly, that is the correct, it's not truncated in any way, so 34.125. 34.125. So now we can find A. We can say that side A over sine of my answer, I'm not taking that out of the calculator, is going to be equal to, take our pick. I'll work with this one because trying to plug that back in is going to be a bit of a hassle. So we can say it's equal to 12 over sine 81. So all we need to find A is 12 sine answer. Remember, answer stuck in my calculator over sine 81. And we're going to get to that angle. And this is one of the many ways you can do it. So what we can say, A is going to be equal to 12. And I've not truncated these answers, so these are the exact answers throughout over sine 81. And we'll get our value of A. 6.815, so we'll call it 6. What are we working in? 6.82. 6.82, and that's going to be well, units, or call it centimetres. So there we go, that's how we can work and keep that level of accuracy and keep it nice and clean, nice and correct. Okay, Nottingham is 40 kilometres due north of Leicester. Okay, so automatically that's a north line. So we can say that that's a north line, that's brilliant, just there, that's fine. So that's going north. Swadlincote is 32 kilometres from Leicester and 35 kilometres from Nottingham. Calculate the bearing of Swadlincote from Leicester. So what we're interested in is the bearing. So we want, remember, this now is, in fact, let's just jot that back. We want the bearing. Now bearings are measured clockwise. They measured 3 figures, and they're measured from north. So we're interested in the bearing here. Now, how can we find that? Well, if we think we've got a cosine problem, this is, again, one of the many ways you can do this. So if we look at what we've got here, and this part here, what I'm going to do is find this angle. So this angle here is going to be the following. We can use the cosine rule. So that angle, we've got 3 known sides. 40, we've got 32, and we've got 35. So if I want this angle, we'll call this angle A. Remember, this is A, this is B, and this is C. Big A, and so on. So we can set it up, we can find that angle. We know that cos A is equal to B squared plus C squared minus A squared over 2BC. Or we can just write it as A is equal to cos to the minus 1 of, now, B squared, which is going to be 40 squared, plus C squared, which is going to be 32 squared, minus A squared, which is 35 squared, all over 2BC. And B is 40, and C is 32. So, if I want this one right here, this bearing, then all I'm going to do is 360 minus my answer. Okay, and that will give me that bearing right the way around here. So in a calculator, again, we can do this in one go and keep it accurate. We're in degrees. So 360 minus cos to the negative 1, so shift cos, of 40 squared plus 32 squared minus 35 squared all over 2 lots of, and again, your brackets, how you use brackets is up to you on this, 32. And this will give us our exact answer. And the bearing is going to be 303.12 degrees. So depending on your level of accuracy, you might be told 4 significant figures. So 303.1 degrees. And that is correct to 4 significant figures. So that's yet another example of how we can use trig on problems. We were not told use the cosine to find. Even if we did use the cosine, all the cosine would have done is found us this angle. We've had to take a bit of a sort of a sideward step and realise that we're finding the bearing, the outside bearing. To calculate the height of a church tower, a surveyor measures the angle of elevation of the top of the tower from 2 points 50 metres apart. The angles are shown in the diagram. Calculate the distance BC. So BC is going to be this one just here. BC up to there, that's fine. Hence, calculate the height of the tower CD. If we think about what we've got here, we've got some information that we can work out the values of. Let's look at this. This angle right here has got to be on a straight line. So this one and this one have got to equal up to 180. So that one is 133. And for the record, if that's 133, add these two together, you're going to get 173. That one up there is going to have to be, what's that, 7 degrees, 180 in total. So 133 is going to stack up to my 180. And then on this one, this is going to be 7 degrees. So what we want to find out is this length right here. We don't have the information about these two, but if we draw this up, and again, stepping aside every now and then, will just show you exactly what you've got, and I'll draw it slightly different to give us a bit more room. This angle right here is 133 degrees. This one is 40. Now, we're told this one here is 50, and we want that one just there. So, by working out that this as well is 7 degrees, we can do that. What we can say is x over sine 40 is the same as 50 over sine 7. So let's work it out then, and that will give us this length right here. So we can say x over sine 40 is equal to 50 over sine 7. That will now give us this value, and there are a few different ways you can attack that and approach that, but essentially getting BC is going to use the sine rule. Okay, so now we can see that x is going to equal 50 lots of sine 40 over sine 7, and that will give us BC. So let's put that through the calculator. So what we're going to have now is 50 sine 40. Okay, and that's over sine of 7 degrees. 263.71. So that distance is 263.71, or we'll put it as 263.7. And that's, again, put your whatever level of accuracy they ask for. If they ask the 4 significant figures, 263.7. Okay, and that's going to be meters. That's perfect now, because all we've got to do is use another bit of basic triangle, right angle trig. We've now got the hypotenuse of a right angle triangle. So in my calculator is the answer. That is the answer to that length. And this is 47 degrees. And we want this side. This is the opposite, and that's the hypotenuse. So Cartoa kicks back in, and we start using, so let's just put that up there. We want the opposite. So all we've got to do is my answer multiplied by sine 47, and this will give me the height. So my answer multiplied, so all I've got to do is press answer multiplied by sine of 47, and we're going to get that height. That height is 192.9, correct to 4 significant figures. So 192.9 meters, correct to 4 significant figures. So we've used the sine rule in a long way round by finding missing angles, and as I say, there are different ways you can do this, and I'm doing them off the top of my head, so there may even be a slightly better way, but it's showing you that how you can put all of this together. We've not been told to use a sine rule, we've not been told that we need to use right angle trig as well. We just end up taking that for granted, and we just use our skills. So there we go, 3 nice little problems that have hopefully opened, well, if you already knew them, cool, but if not, have just given you a bit of an insight into how you can problem solve.